Hey guys, Mr. Schmitz here. Wish I could be back in the classroom with you guys, but as you know, I'm sure Mr. Z told you, I got hit with a positive COVID test on Monday. I'm doing all right, feeling pretty good, but we're going to try and do some different things. I'm going to try and pop in on Zoom and see you guys too every once in a while, but we're going to try this video for today, just so you guys don't miss out on anything, because I know you guys are all upset, but you will not get to see me back in the classroom until the 14th, which is next Friday. So we're going to check out videos like this. Hopefully they work well and you guys are able to follow along and pick up the content. So because you guys are all fantastic students, I know you already have your 5.4 notes out and on your desk ready to go. You haven't lost them from when I gave them to you in December, and we're not going to have any issues. Who am I kidding? Mr. Z, you're probably going to have to pause the video. These guys are going to have to rummage through their backpacks for 30, 45 seconds trying to find them, realize they lost them, and then you might as well just get out a blank sheet of paper and take notes, because you will have to turn these in with your homework, just like we've always been doing the whole school year. So let's take a look at what we're doing here. Yesterday, you guys should have completed a review pizzazz of inequalities, just addition, subtraction, multiplication, division, basic inequalities. Today we are stepping it up and we're going to talk about compound inequalities. So a couple things to remember. Number one, solve them just like you would equations. Okay, inverse operations, whatever you do to one side you have to do to the other. Number two, if you multiply or divide by a negative number, inequality signs flip. That still applies today. So if we take a look at number one here, we have a compound inequality, which just means there are two inequality symbols instead of one. The process doesn't change. We are still solving for x. We are still trying to get it by itself. So we are going to identify where x is in the middle here. We have x plus 5 in the middle, 2 on the left side, 9 on the right side. Inverse operation still. So we are going to subtract 5 from the middle. Now, with compound inequalities, whatever we do to the middle, we must do to both sides. So we are going to subtract 5 from the left side, and we are going to subtract 5 from the right side. As I do this, 2 minus 5, negative 3, keep the inequality symbol, is less than, inverse is canceled, so x is less than, 9 minus 5 is 4. X is by itself. So this is our compound inequality. We are still graphing, so I'm going to have you guys draw a number line. In this case, we don't need to put 0 in the middle because we've got two boundaries already. But we're just going to put negative 3 on our number line, and we're going to put 4 on our number line. Now, as we graph here, we're going to take the relationship between x and negative 3. So if I start at x, the open side is facing x, which means greater than. So x is greater than negative 3. If you remember, a greater than symbol is an open dot. If x is greater than, this is going to start going to the right. Then go back to x, see what its relationship is with 4. So the closed side is facing x, so x is less than 4. So I still have an open dot, but now this one's going to go to the left. So I now have two open dots, and they are going to connect in between. X is greater than negative 3, and x is less than 4. The solutions are between negative 3 and 4. Okay? Let's try one more together, and then we'll go ahead and I'll have Mr. Z pause the video, or if you're watching this from home, you can go ahead and pause the video, and I'll let you try a couple by yourself. So, taking a look at number 2 here, same thing. We're going to start with inverse operations. So, we have 2y plus 4 in the middle. First thing we have to get rid of is the plus 4. The inverse, let's go ahead and subtract 4 from all three sides. 10 minus 4 is going to give me 6, is less than or equal to 2y, is less than or equal, 24 minus 4 is 20. Now, inverse operations, 2 times y, the inverse, we're going to go ahead and divide by 2. Same thing, if we divide in the middle, we have to divide by that 2 on all 3 sides. 6 divided by 2 gives me 3, still less than or equal to. Inverses cancel, left with just y, less than or equal to 20 divided by 2 is 10. So I now have my compound inequality that I can go ahead and graph on my number line. Put our two ends, 3 and 10. We have greater than or equal to, greater than or equal to. So we're going to have two closed dots. Remember that equal to symbol makes it from an open dot to a closed dot. Now let's look at the relationship between y and 3. The open side is facing y, so y is greater than or equal to 3. Greater than is to the right. Closed side is facing y for y and 10, so y is less than or equal to 10. Less than is to the left. This is once again going towards each other or connecting between 3 and 10, meaning all of our solutions are between 3 and 10 and also including 3 and 10. So that should give you guys the idea of what we're doing. So why don't you guys keep these two in front of you, and I'm going to have Mr. Z go ahead and pause the video, and I want you guys to try number 3. And then when you guys have attempted number 3, go ahead and unpause the video. I'll run through it real quick with you, make sure you guys are on the right track. And then we'll go ahead and pause again and do number 4. And then you guys can follow along through number 4 to make sure you're on the right track. So go ahead now, pause the video, try number 3 on your own. And then when you are finished, go ahead and unpause the video and make sure you're on the right track. So as we take a look at number 3 here, inverse operations. -3, inverse is to add it to both sides, or all 3 sides. -5 plus 3 is -2, less than or equal to. Inverses cancel. -x, less than or equal to. 2 plus 3 is 5. Now, hopefully you remembered, if you have a -x, it's really like a -1x. So -1 times x, the inverse is to divide by -1. When I divide by -1 on all 3 sides, -2 divided by -1 is +2. Remember, divided by a negative, flip your inequality symbols. Greater than or equal to. X, inverses canceled. Greater than or equal to, it flips both of them. -5. Now we can go ahead, graph it. This one can be tricky too. -5 and 2 are our limits. Which one is smaller? -5, it goes on the left. Your number line should always go smallest to largest. Greater than or equal to symbols. So we will have closed dots. Now let's look at our relationship. This is between 2 and x. Closed side is facing x. So x is less than or equal to 2. Start at 2. Less than is to the left. Open side is facing x for -5. So x is greater than or equal to -5. Greater than is to the right. Closed dots meeting in between. Now, go ahead, pause the video again, try number 4, and then let's come back and we will walk through number 4 as well. So, using our inverse operations again, hopefully you started by getting rid of this +2 by subtracting 2 from all 3 sides. When you do that, -1 minus 2 is -3 is less than or equal to. Inverse is canceled. -5x is less than or equal to. 4 minus 2 is 2. Now, we got to get rid of the -5, so I divide by -5 on all 3 sides. -3 divided by -5. 5 doesn't go into 3, so we're just going to leave it. But a negative by a negative gives me a positive. Flip the inequality symbols. We divided by a negative. Inverses cancel, just x in the middle. Flip the inequality again. -2/5 on the right side. So if we graph this one, our bounds now, -2/5 and 3/5, smaller one, goes on the left, which is -2/5. 3/5 goes on the right. That's our larger bound. We have equal to in both inequalities, so we got some closed dots here. And starting with 3/5, closed side is facing x, so x is less than, that's going to go to the left. Greater than, open side is facing x for this one, so it's going to go to the right. So x is greater than or equal to -2/5 to the right. This one, once again, goes towards the center. Now, I bet you noticed that on all 4 of these, they connected in the middle. That will not always be the case. As we flip it over here, you'll notice these compound inequalities on the back have the word or in between them. The ones on the front did not have anything. They were just compound inequalities all smushed into one. The 4 examples on the front are what we call AND compound inequalities. A, N, D, AND. Both are true at the same time. Every number in this solution set is greater than -3 and it's less than -4. This one, everything in the solution set is greater than -3 and it's less than 10. For numbers 5 and 6, a little bit different here. We have or. So it is going to be one or the other, but not both. So let's walk through number 5 together. Then we'll pause the video. You guys can try 6, and we'll make sure you're on the right track. So these ones, or is exactly like what we were doing before break. You're going to almost treat them as 2 separate inequalities. So let's go ahead and subtract 3. 2x is less than 6. Divide by 2. X is less than 3. That's one of our solutions. Now we do the other side. Add 6. 3x is greater than 18. Divide by 3. And x is greater than 6. Here's our 2 solutions this time. Now we're going to go ahead and graph these on our number line. 3, 6, not equal to, so they're going to be open dots. And now let's look. Closed side is facing 3, so x is less than 3. This one's going to go to the left. Open side facing x, so x is greater than 6. This one is going to go to the right. You'll notice or statements should always go away from each other because it's one or the other. And statements will always go towards each other because both are going to be true. So why don't you guys pause the video, go ahead, try number 6, and then we'll bring it back and make sure you guys are on the right track. All right, so first step here, we're going to go ahead and subtract 1. 4c is less than or equal to -4. Divide by 4. And your first solution is c is less than or equal to -1. Second solution, add 3. 5c is greater than 20. Divide by 5. c is greater than 4. If we go to graph this, we've got -1. We've got 4 closed dots. C, closed side is facing C, so C is less than -1. That one's going left. Open side, oh, hold on, we made a mistake here. Hopefully one of you caught it and is yelling at the screen. This one, we just have a greater than sign, so this is actually going to be an open dot. C is greater than 4. This one's going to go to the right. All right, looking forward here, we are now going to take some verbal sentences and translate them into compound inequalities. So the best way to do this is you need to identify your unknown and your 2 sides or your 2 limits. So number 7 says all real numbers are greater than -2 and less than -3. So our limits are right there. We know we're going to have -2 on one limit and 3 on the other. All real numbers. We don't know what real numbers, okay? So those are our unknowns. That's going to be x. That's what we're talking about. So if these unknowns, or x, are greater than -2, then the open side has to face x. X has to be open side greater than -2. These unknowns also have to be less than 3. So if they're less than 3, closed side facing x, x is less than 3. This would be our compound inequality. Notice it's an and statement, so that we have one giant compound inequality versus having two separate ones separated by or. Why don't you go ahead, pause the video real quick, try number 8 on your own, and then hit play again and see if you're on the right track. All right, so all real numbers are less than 0 or, keyword here, greater than or equal to 2. So our limits, 0, 2, all real numbers again, those are unknowns. Not going to go in the middle this time, though, because we have or. So or means we're going to have two separate inequalities. So x has to be less than 0, so closed side faces x, or greater than or equal to 2. So open side equal to, there is our compound inequality with an or statement. And last problem here. I want you guys to try this one. I want you to pause the video again. Try number 9, and then I will take you through it to see if you got the correct compound inequalities. So, a crane sits on top of a camera car, faces towards the front. The crane's maximum height and minimum height above the ground are shown. Write and graph a compound inequality that describes the possible heights of the crane. So, we've got a crane, and we've got our two boundaries here. We've got 4, and we've got 18. Now, think logically here, guys. A crane, is it going to move in between our two limits or outside of our two limits? Okay, a crane has to move in between those limits. So if we are in between, it has to be an and statement. So our unknown is going to go in the middle. If the maximum height is 18, our unknown has to be smaller than 18. It can be equal to, because it can hit 18 feet. If 4 is our minimum value, our unknown has to be bigger than 4, so the open side has to face x, but it could also be equal to, because the crane can go to 4 feet. So our compound inequality here would be 4 is less than or equal to x is less than or equal to 18. And that's it. You guys have survived compound inequalities. Now, you also have a homework assignment that is listed on Mudge, so please make sure you get that in to me tonight or by tomorrow morning, by the time class starts tomorrow, and we will go from there. Have a good rest of your day, fellas. I will see you or talk to you again tomorrow.